This is my physics project for summer of 2020 by Max George. It is titled Dermatology and Lasers. So, lasers are a very important tool. They are widely used in the industrial, medical, and research world. One field which has relied heavily on them that I'm interested in as a pre-med student is dermatology. Dermatologists use lasers for a variety of medical procedures, especially in cosmetic things like removing unwanted body hair, tattoos, birthmarks, warts, and scars. So what is a laser? A laser is an acronym for light amplification by stimulated emission of radiation. In 1917, Albert Einstein came up with the theory that when atoms from an object are filled with excess energy, they will emit light photons, following the law of conservation of energy. This in turn causes other atoms to also emit photons, with the important caveat that all the photons emitted will have the same direction, energy, and wavelength. So to make this idea work practically, the material to be filled with energy must do so via another light source or electrical current. Once this has been done, the energized emissions are then amplified due to being bounced around in a mirror cavity. The light photons bouncing around in the cavity cause the increased emission of photons from other atoms. Then in the mirror cavity is a transparent section through which a concentrated beam of this excited light emission can escape. So a laser will have four main components. It'll have its laser medium, so that's material in the optical cavity, which can be solid, liquid, or gas. In dermatology, lasers will usually have a solid medium. The optical cavity itself will contain the laser medium and is the location of the amplification process. And the power supply will supply the laser with energy through a variety of methods, including electrical currents, chemical reactions, and optical stimulation. And the delivery system is how the light is focused for delivery. So on this ruby laser here, the power supply is back here in the gold square. The optical cavity is this cylinder in which the laser medium, this red ruby, is, and the beam is focused out that small hole. So an important part of how lasers work is the atomic structure. So the atom consists of a central nucleus with electrons orbiting in different orbital levels. The orbitals will have different energy levels, and naturally atoms try to remain in their lowest energy state possible. But when they absorb a photon of light, the atom is forced into a higher energy orbit, which is more unstable for the atom. So under normal circumstances, the atom quickly emits this photon and returns to the lower energy state. But with lasers, the laser cavity is used to create a population inversion where the atoms are forced to remain in high energy unstable states. So they're constantly producing lots and lots of light photons. So the population inversion is critical for producing the concentrated light beams with high energy. And because since it is the amplification of light, a laser is a type of wave. So light is a transverse wave where the disturbance occurs perpendicular to the direction of travel of the wave, as opposed to longitudinal waves where disturbance is parallel to the direction of travel. So the longitudinal wave is like your classic slinky with coming apart and going across, and your transverse wave, it's going up and down. So for a laser, its wavelengths are concentrated into this narrow beam, like this, like the GIF up in the corner. And this is because all the waves in the beam have similar wavelengths whose peaks are lined up. And this is termed as the laser is traveling exactly in phase, which also makes the optical cavity a coherent source for the wave. So the amplification process in creating a laser will make a wave with high amplitudes, and the higher the amplitude is of a wave, the higher energy it will be. Since a laser beam is very concentrated and the light does not dissipate, they are able to transport a great deal of energy to a small target over a great distance. So radiation and lasers. So as light waves, lasers also will fall into the category of electromagnetic waves. And a key feature of those is radiation. So radiation is the process of energy transfer via electromagnetic waves. For medical purposes in dermatology, the amount of energy that lasers transport can be problematic. Because of the law of conservation of energy, energy which is not absorbed is given off as heat. The high energy nature of lasers carries the risks of serious burns and scarring if used incorrectly in medical procedures. So the basics of it is that dermatology uses lasers to target specific molecules with energy. Understanding how the laser interacts with these molecules is critical to use them. Um, and so, as I already said, the excess energy will be given off as heat, so this can potentially harm surrounding tissue. But lasers will effectively work by burning targeted areas in the integumentary system. So to safely use them, you have to find your way to reduce the possibility of skin burns due to the high energy of the laser beam. So one of the ways that they do this is to use a pulsed laser. So a pulsed laser sends pulses of light out in between which no light is emitted. So the period for a pulsed laser is the time from the start of one pulse to the beginning of another. So with medical effects due to lasers occur when the desired tissue of the integumentary system absorbs the laser's light. Absorption of this light is determined by the specific wavelength a molecule will absorb. And there are three major molecules that are typically targeted. The term for them is chromophores, and they are water, melanin, and hemoglobin. So the theory of selective thermolysis was proposed by Anderson and Parrish in 1983, and this basically states three principles for laser use in order to successfully destroy a cutaneous target without damaging or minimizing damage to surrounding healthy tissue. So the first is wavelength. So the wavelength of the laser should be used that the intended chromophore is able to absorb it. The second is the laser pulse duration. So the duration of the pulse should be shorter than the time it takes the chromophore to lose half its peak energy after being heated. And then the fluence is the energy the chromophore is targeted with should be able to destroy it within a reasonable time frame. So here I have an example. So in this picture, this baby has been born with port wine stain, which is a very visible birthmark, and it's formed due to improperly formed blood vessels. So to remove them, in one example, a laser with a diameter of 30 to 100 microns with a pulse laser duration of 0.4 to 20 milliseconds and a thermal relaxation time of 1 to 10 milliseconds is used to target the hemoglobin molecules in the stain. So this destroys them and allows the baby to not have this scar or this birthmark on its face for its whole life. And then just mathematically, so there's two major factors for laser effects on tissue and for treating skin conditions. One is irradiance, which is the ability of the laser to incise, coagulate, or vaporize tissue and can be mathematically determined. And it basically is the power the laser strikes an area with. So it is laser output in watts times 100 divided by pi radius squared of the laser beam, and it's measured in watts per centimeters squared. And then the second is energy fluence, which is how much laser energy can be transmitted in a single pulse, so it's laser output in watts times exposure time in seconds divided by pi r squared of the laser beam, and its units are joules per centimeters squared. And for both of these, their effect is directly proportional to their number. A higher number leads to a greater effect and lower number to a lessened effect. So in conclusion, lasers are high energy, high amplitude waves traveling perfectly in phase. Due to this, they can transport a large amount of energy to a small target. Dermatologists take advantage of this in the absorption spectra of various cutaneous molecules to treat skin conditions. In order to safely and successfully do this, the three tenets of the theory of selective thermolysis, which are wavelength, fluence, and thermal relaxation, must be observed. And these are my references. Thank you.